ሰላም ውድ የማትስ አካዳሚ ቲዩብ ቤተሰቦች እንደምናችሁ። በተለይ ይህንን ቪዲዮ ለምታዩ የዩኒቨርሲቲ ተማሪዎች ከዚህ በፊት አፕላይድ ዋንን በተመለከተ አሉ የተባሉ ጥያቄዎችን በሙሉ ሰርቼ መልቀቄ ይታወቃል። አፕላይድ ዋንን በተመለከተ ያልሰራው ጥያቄ ካለ ኮሜንት ቦክስ ላይ ጻፉልኝ። እንደተለመደው ከሰፊ ማብራሪያ ጋር ቪዲዮ ሰርቼ መልቀቅላችሁ ይሆናል። ቪዲዮዎችን ያላያችሁ ቻናሌን ሰብስክራይብ በማድረግ ገብታችሁ ማየት ትችላላችሁ። ዛሬ ደግሞ በዚህ ቪዲዮ አፕላይድ ቱን በተመለከተ እዚህ ስክሪን ላይ የምታዩትን ወርክሺት እንድሰራላችሁ የጠየቃችሁኝ ተማሪዎች መልሱን እንደሚከተለው ይዤ ቀርብ ያለሁኝ። አብራችሁን ቆዩ። So the first question says, using the definition verify these limits. እነዚህን ሊሚቶች ቬሪፋይ አድርጉ ነው የሚለው። ዴፊኒሽን ኦፍ ኮንቨርጀንት ሲኩዌንስን በመጠቀም እነዚህን ሊሚቶች ቬሪፋይ እናደርጋለን። but first you need to see the definition of convergence of a sequence. So let an be a sequence and capital L be a real number. Then we say the sequence an converges to some number L, or the limit of an is capital L. We use this notation. This means an is approaching L, or the limit of an as n approaches to infinity is L. This happens if for every epsilon greater than 0 there exists a positive integer n which completely depends on epsilon, satisfying this condition. ይሄንን ኮንዲሽን ሊያሟላ የሚችል for every epsilon greater than 0 we need to find such n. So this is the formal definition of convergence of a sequence. ይሄንን definition ይዘን እንመጣና እዚህ ጋር apply እናደርጋለን። So the first question is, using the definition verify the convergence of the following limits. እነዚህ ሊሚቶች verify እናደርጋለን based on the definition that we have seen before. So let's see the first part. A ላይ ያለው ምን እንደሚመስል እንይ። In A the sequence is n is equals to 2n minus 1 over n plus 1. The limit as n approaches to infinity 2 ነው ማለት an will be approaching to the value 2 for n becomes infinity. So L alan, this 2 is L. So this 2 is L based on the definition that we have seen. So here is the procedure. Always we start by assuming epsilon greater than 0. So assume that there is epsilon greater than 0. We must find capital N such that for every small n greater than or equals to n, the inequality absolute value of 2n minus 1 over n plus 1 minus 2 is less than epsilon. ይሄ ቀጥታ በዴፊኒሽኑ መሰረት በኤን ቦታ ይሄን እናስገባለን፣ በኤል ቦታ ይሄን እናስገባለን። ኢንኢኳሊቲውን እንደዚህ አድርገን እንጀምራለን። So this is the first step in verifying the convergence of a limit. Then next we usually observe the things here. Observe that the absolute value of 2n minus 1 over n plus 1 over n plus 1 minus 2, this is the same as 3 over absolute value of n plus 1. Obviously this is the same. check ማድረግ ትችላላችሁ። ይሄን simplify ስታደርጉ ይሄንን ነው የምታገኙት። So obviously this is less than 3 over n. okay, ከ3 over n ያንሳል ማለት ነው። for all n greater than or equals to 1, this is true. You can check. Now it suffices to find the value of n satisfying capital N that satisfies small n greater than or equals to n implies 3 over n is less than epsilon, right? Okay, 3 over n less than epsilon. From this, we can see that n over 3 is greater than 1 over epsilon by reversing, by taking the reciprocal. So this implies n is greater than 3 over epsilon. Okay, now we can choose capital N to be 3 over epsilon. Okay, for such choice, the inequality that we have here will be true. Therefore, we can say that the limit of 2n minus 1 over n plus 1 as n approaches to infinity is 2. This is how we verify the convergence of the sequence in A part. Now let's see the B part. Here is the solution for the B part. A ላይ ያየነውን procedure እንደግመዋለን. So we always put the sequence an, which is 3n squared over 5n squared plus 1. This is our an, and this sequence is converges to 3 over 5 as n approaches to infinity terminal. So always we start by assume that there is epsilon greater than 0. So we must find, based on the definition, we must find capital N such that for all n greater than or equals to capital N, the inequality 3n squared over 5n squared plus 1 minus 3 over 5, this must be less than epsilon. So we need to find such n. So now observe this absolute value. Observe that the absolute value of 3n squared over 5n squared plus 1 minus 3 over 5. This is simplified to, in simplification another 3 over, you can crisscross and obtain this. This is the same as 5 times the 5n squared plus 1. Okay, so these two are equivalent, they are the same. So this is less than or equals to, it can be strictly less than, so 3 over 5n squared plus 1. ይሄ እውነት ነው። ይሄ strictly less than መሆን ይችላል። Still this is also less than or equals to 3 over 5n squared. This is again less than or equals to 3 over 5n. This works for all n greater than or equals to 1. You can check. ስለዚህ እዚህ ጋር የሆነ ቴክኒካል ነገር እንጫወታለን ማለት ነው። So ይሄ absolute value strictly less than 3 over 5n ነው ማለት እንችላለን። So from this observation we can see that the 3n squared over 5n squared plus 1 minus 3 over 5 is less than 3 over 5n ማለት እንችላለን። This works for every n greater than or equals to 1, as you can check. ከዛስ ይህን strictly less than epsilon ማድረግ እንችላለን, right? እዚህ ጋር ስለተነሳ okay. So if this happens, this implies 3 over 5n is strictly less than epsilon. ከዚህ inequality ምን ማግኘት እንችላለን? 5n over 3 is greater than 1 over epsilon ማለት እንችላለን። So this leads us to n greater than 3 over 5 epsilon, right? 5 times epsilon ወደዚህ ይመራናል ማለት ነው። ይሄንን ያዙልኝ። n is greater than 3 over 5 epsilon. Okay, so our objective is to find this capital N with satisfying this condition. Okay, now you can choose capital N to be any number greater than or equals to 3 over 5 epsilon. ይሄን ቁጥር መሆን ይችላል፣ ከዚህም ከፍ ያለ መውሰድ እንችላለን። So in this case, for such choice, the given inequality, absolute inequality, will be true. Therefore, the definition is satisfied. So the limit of 3n square over 5n square plus 1 as n approaches to infinity is 3 over 5 እንላለን። Okay. Now let's see the verification on C. In C, we do have the sequences an is equals to radical n plus 1 minus radical n. This is our an, and capital L is 0. Okay, so this sequence approaches to 0 whenever n is goes to. So this sequence is approaching to 0 whenever n is approaching to infinity. So as usual, we start by assuming assume that epsilon is a small positive number. So we must find capital N such that for all small n greater than or equals to n, capital N, the inequality radical n plus 1 minus radical n must be less than epsilon. This condition must be satisfied. So now let's observe that the absolute value of radical n plus 1 minus radical n is the same as the absolute value of radical n plus 1 minus radical n times radical n plus 1 plus radical n over radical n plus 1 plus radical n. Okay, ይሄ ምንድነው እዚች ጋር ያደረግነው rationalize ነው ያደረግነው. So this is equivalent to 1 over radical n plus 1 plus radical n ይሆናል under the absolute value. Okay, since n is positive, this absolute value may not be required. So from this observation, we can have also the absolute value of radical n plus 1 minus radical n. This is equivalent to 1 over radical n plus 1 plus radical n. This is less than or equals to 1 over radical n plus radical n. This is equivalent to 1 over 2 root n. So this is strictly less than 1 over radical n. This inequality works for every n greater than or equals to 1. ለማንኛውም ከአንድ ጀምሮ ላለ n value ይሰራል ማለት ነው። So from this observation, we can see that for n greater than or equals to capital N, we can observe that 1 over root n is strictly less than epsilon. ይሄን ያዙልኝ፣ ይሄን ያዟት። So again here we need to observe that from 1 over root n less than epsilon, ምን ይኖረናል? root n is greater than 1 over epsilon. Okay, reciprocal ስናደርግ inequalityውም ይዞራል. So this implies squaring both sides. This implies n is greater than 1 over epsilon the whole square. Okay, አሁን የምንመርጠውን ካፒታል ኤን እናገኛለን። now we can choose any number starting from 1 over epsilon the whole square. You can choose capital N can be any number 1 over epsilon the whole square or bigger. So for such choice, the inequality that we have here is satisfied. Therefore ምን እንላለን ማለት ነው? the limit of root n plus 1 minus root n as n approaches to infinity is 0 እንላለን። እዚህ ጋር በደንብ ልታስተውሉ የሚገባው ሊሚት መፈለግ ሌላ ነው፣ ቬሪፋይ ማድረግ ሌላ ነው። ሁለት የተለያዩ ነገሮች ናቸው። ሊሚት ካልኩሌት አድርጉ የሚል ጥያቄ 12 ያክል ተጠይቃችኋል። አሁን ደግሞ ሊሚት መፈለግ ሳይሆን ሊሚቱን ቬሪፋይ ማድረግ limit of a sequence የተሰጠውን ነምበር እንደሚሰጠን verify ማድረግ ነው። Suppose an and bn are sequences with this condition, the absolute value of an is less than or equals to the absolute value of bn for all n greater than or equals to 1. Show that if bn converges to 0, then an also converges to 0. So let's use this information properly. It's given that the absolute value of an is less than or equals to the absolute value of bn for all n greater than or equals to 1, and bn converges to 0. That means the limit of bn as n approaches to infinity ምን ይሆናል? bn ወደ 0 approach የሚያደርግ ነው ተብለን። So the question is, we are asked to show bn, an converges to 0. በሌላ አባባል ምን ማለት ነው? the limit of an as n approaches to infinity ምን ይሆናል ማለት ነው? 0 ይሆናል ማለት ነው። or an goes to 0 whenever n is becoming large ማለት ነው። ይህንን ነው የምናሳየው። So we start from some fact. Note that always the negative of the absolute value of an is less than or equals to an. This is less than or equals to absolute value of an. And the negative of the absolute value of bn is less than or equals to bn. This is less than or equals to absolute value of bn. For all n, this works for all n. ለማንኛውም ሲኩዌንስ የሚሰራ ነገር ነው እነዚህ ሁለቱ ነገሮች። So if we have this, since it's given that absolute value of an is less than or equals to absolute value of bn, ይሄ ስለተሰጠን ምን ማድረግ እንችላለን? This leads us to the inequality minus of the absolute value of bn is less than or equals to an. This is less than or equals to bn. Again, this is less than or equals to absolute value of bn. From the given information, we can draw this inequality. And inequality ማግኘት እንችላለን. So we take the limit on this inequality. በእያንዳንዱ ሳይድ ሊሚት እንሰራለታለን። So from this, we can see that the negative of the limit of the absolute value of bn as n approaches to infinity is less than or equals to the limit of an as n approaches to infinity. This is less than or equals to the limit of bn as n approaches to infinity. ይህችን ብቻ for some purpose ወስጃለሁ። So this is equivalent to the negative of the absolute value of the limit of bn as n approaches to infinity is less than or equals to the limit of an as n approaches to infinity. This is again less than or equals to the limit of bn as n approaches to infinity. እዚህ ጋር ምን ተሰጥቶናል? the limit of bn as n approaches to infinity or bn converges to 0 ተብለናል። so ይሄ ነገር 0 ይሆናል ማለት ነው። again absolute value of 0 ምንድን ነው የሚሆነው? 0 ነው የሚሆነው። negative of 0 is 0 which is less than or equals to the limit of an as n approaches to infinity. so ይሄ ሲኩዌንስ በ0 እና በ0 መካከል ነው ስንል ምን ማለታችን ነው? ራሱ ሲኩዌንሱ I mean ሊሚቱ the limit of an as n approaches to infinity is 0 ማለታችን ነው። therefore ምን እንላለን ማለት ነው? therefore the sequence an converges to 0 እንላለን ማለት ነው። በሌላ አባባል an is approaching to 0 for n large number ማለታችን ነው። let an and bn be sequences. if an converges to 0 and bn is bounded, show that the sequence an times bn converges to 0. so let us put the given information properly. የተሰጠውን ነገር properly እናስቀምጥ። it's given if an converges to 0 and the sequence bn is bounded, okay, then we want to show that or we are asked to show that the sequence an times bn converges to 0. ይሄ ወደ 0 approach እንደሚያደርግ ነው የተጠየቅነው። or an times bn ወደ 0 approach እንደሚያደርግ አሳዩ ነው የሚለው። so from here an approaches to 0 ማለት ምን ማለት ነው? the limit of the sequence an as n approaches to big number is 0 ማለታችን ነው። and bn is bounded ማለት this sequence is bounded ማለት the absolute value of bn is less than or equals to some constant m for some m an element of real number. okay, bounded ማለት ይሄ ነው። ማንኛውም terms of the sequence በተወሰነ ቁጥር መካከል ነው ማለት ነው bounded ማለት። so we have this information. እነዚህ ኢንፎርሜሽን ተሰጥተውናል። so ከነዚህ ተነስተን ምን ልናሳይ ነው? the sequence an bn ወደ 0 approach እንደሚያደርግ እናሳያለን። so absolute value of bn less than or equals to m ወይንም bn bounded ነው ማለት ምን ይነግረናል? ይሄ there is some negative m less than or equals to bn, this is less than or equals to m ማለት ነው። okay, ምን እንደ ማለት ነው? absolute value of x less than or equals to a ካለ ሁሌም this is the same as minus a less than or equals to x less than or equals to a ማለት ነው based on the property of absolute value። ይሄ ነገር አለን። say this is equation 1. now we will have different cases. የተለያዩ ኬዞች ይኖሩናል። in case 1 if all the terms of the sequence is greater than 0, okay, if all the terms of the sequence an is positive, okay, using equation 1 we will have this thing minus m times an is less than or equals to an times bn, this is less than or equals to an times m. okay, equation 1 both side by an አበዛን ማለት ነው። now we can take the limit in each side. ሊሚቱን ስንወስድ the limit of minus m times an, this is less than or equals to the limit of an times bn, this is less than or equals to the limit of m times an. okay, ይህን እናገኛለን። we can take the limit on both sides. on all side limit ወሰድን። now this is equivalent to this is equivalent to ይሄ ምን አለን this is equivalent to the negative of m times the limit of an as n approaches to infinity. This is less than or equals to the limit of an times bn as n approaches to infinity. This is less than or equals to m times the limit of an as n approaches to infinity. አሁን እዚች ጋር ምን አለን limit of an ይሄ 0 ነው ተብለናል። so this is 0 so ይሄ inequality ምን ይሆናል ማለት ነው negative m times 0 which is 0 less than or equals to the limit of an times bn as n approaches to infinity. This is less than or equals to 0. ይሄ ምን ይነግረናል ማለት ነው the limit of an times bn as n approaches to infinity is 0 ነው ማለት ነው። Therefore in case 1 we can see that the sequence an times bn ወደ ምን approach ያደርጋል ማለት ነው it converges to 0 እንላለን። case 1 እንደዚህ ነው። case 2 ደግሞ ምን ብለን assume ማድረግ እንችላለን case 2 ለእናንተ ተዋለሁኝ ምክንያቱም ተመሳሳይ ስለሆነ in case 2 you can assume if all the terms of the sequence an is negative okay inequality 1ን እዚህ ውስጥ እንመጣና በan እናበዛለን and we apply squeezing theorem so that we can observe that the sequence an times bn converges to 0 for the given condition. Okay.